Hello, everyone. Welcome to today's Vibe Coding live session. Thank you for joining us. What I thought today is we would go through a little bit about building applications, because it's probably one of the most requests that I get is how can you turn an idea into something that you can actually utilize? And I think this is where Vibe Coding genuinely has some of its most value. Is everybody's often looking to scale. They're looking at the way of being able to build products that they can go and sell or go and put on an app or whatever it might be. But actually, if you're a small team, sometimes you just need something that's really specific that works for your team, for the work that you do. It doesn't have to be the most scalable product in the world. It just needs to work for the people that it works for. So essentially, we're going to be looking through being able to build that. I'll do some explanations along the way of how we're doing it and what's working. You'll see it all visually on our little terminal extension here. So essentially, this extension that you can see in front is a terminal that we've set up that visualizes the code, so you can start to see how it's building, what it's building, and what it's building. So the prompt that I'm going to put in today is pretty much around being able to go and build an application that helps somebody work out whether they should automate the process, whether they should be using an AI on it, or whether the process should remain human. And the whole purpose is that the application we're going to build is going to do that for us. So it's quite a simple application, but it should be one that hopefully gets us to be able to see that we could do this for anything. You don't have to use it for the same kind of thing. You could utilize it for any kind of application that you want to go and build. So there's a few things that we are going to have a look at, but I'm going to start with putting in our prompt in our terminal and getting that going so I can talk you through what it's doing as it's doing it. And don't worry about the whole prompt library. And I think quite often we talk about prompt engineering and stuff like that, which is very 2024. Realistically, nowadays, with the capabilities of AI and what we're looking at people being able to do, is if you can explain it, you can create it. You can give it the context of what it needs to be able to do it. So in the past, it was all about, really tidying up your prompts to get exactly what you want from the model. Now, realistically, I use things like shortcut keys that have voice notes on them. And essentially, I'll just go and talk and be like, I want you to do this, I want you to do that, I want you to do that, I want you to do that. As long as I can explain it, an AI terminal will be able to figure out that information. It has enough context now that you don't have to have really tailored prompts in order to get an outcome. So I have put my prompt in here. Today, I'm going to be using Claude Code with Fable 5, and we'll get things started. And the whole point of these sessions as we're going through is feel free to ask questions. If you've got any thoughts, if there's anything that you want to learn about it on the way, then let's learn it together. I can't promise I got all the answers, but I can promise I got enough of them. So if there's anything that does come up as you're watching this, then let me know. So what you can see on here is we've got our agent, our orchestrator in the middle is starting to be able to run some fundamental commands to be able to kind of give the information, get the information we want. So those little things that you see pop up where it's the green and it's sending information back might just be a script that it's running. It might be some information that it's gathering. That server, where this orchestrator is operating on, that has its own computer to be able to work from. It has a server that it sits in my computer, and essentially it is able to utilize that to do whatever I would be able to do on a computer. One thing that you're also seeing happening at the moment is it's spinning up agents and sub-agents as part of that. So essentially an agent here, we have our orchestrator in the middle, but then what we have around it is our sub-agents that it's spinning up in order to go and complete different tasks. So each of those agents is working like an agent and feeding it back. So you can almost think of this like a team. You have your manager in the middle, and then what you have it doing is it has its employees, its direct reports, literally going out, doing the work and sending the information back. So you can see all of that information gathering as we come through on what's happening here. Let me have a quick read on our terminal, check things are going well. So at the moment, I can see that we have a bunch of agents that have been spun up to kind of start gathering information and start building things as we're working through. So one question that I get quite often is, how do we do this? What kind of setup do we have in order to be able to make this work? And I've created a bit of a visualization to walk you through some of the things that we're looking at right here. So what you can see is that we have a layer to be able to begin with, which is our prompt layer. This is what we do is you type in, you give it your response, you give it the information. examples, context, anything that it needs to be able to go and do it. That's our prompt engineering level. That's if you're utilizing Copilot and you're utilizing it to kind of change your change your email so it has a different tone, or to check spelling and everything like that. That's where you're going to find most people are at with your Copilot licenses and stuff. But then as we move on, we're looking at our context window. So this is where if you start to add in documents, you start to give it a code base, you start to give it, you know, like we're utilizing VS Terminal today, we're giving it all of the folders, all of the files that it has in order to be able to go and complete that project. So it now has the context of what it's working in. It's not just you talking to it, but we've given it extra information. So this might be ways that it can retrieve information, where things are stored. You know, it might be around putting it in memory, having it stored on a hard drive, being able to compact context and things like that. All of that ties into our context windows. That's our context engineering. Then we have what we call the harness. So in this case, this is where what do we give our AI agents that they can go and utilize? So if you're looking at our example of what's going on here, the AI agent here has access to lots of, basically a whole computer, 2 computers to be precise. It has one for local language models and it has a server there with everything else. And essentially that harness is everything that AI agent can access in order to be able to go and complete a task, to be able to go and get things done. So let me quickly flip back to my other animation. So our context could be things, our harness could be things like MCP tools. It could be around giving access via API to our emails, have access to our calendar, to our databases. All of those things are the extra information that it has in order to be able to go and complete tasks. So it's not just about it giving a response. That's, once again, very 2024, was I type something and it gives me a response back. Now I'm going, I actually want you to not just tell me something, I want you to be able to do something. And that's what the harness gives us. And one thing that you hear quite a lot about, particularly over the last few months, is loop engineering. So loop engineering is just the fact that we can have these AI agents run autonomously. My AI agents generally tend to run at 3 o'clock in the morning when computer's cheap, and my electricity is cheap, and also because I don't need them running in the day when I'm trying to do things. So essentially, that is where we have a chronological timer, and that just triggers our agent to be able to go and do stuff. So it could be the case of, like, I've got AI agents that generate reports every morning. You know, what are my competitors doing? What's the big conversation pieces of the day? You know, is there anyone new in the pipeline? All of those things can be done on chronological timers that then start to feed through into your day. So if it's repetitive, involves a lot of text, or you could teach an intern to do it, you could probably get an AI agent to do it, and you could get it to do it at 3 a.m. in the morning before you even wake up. So that's our loop that kind of ties things together. Once again, if you've got any questions along the way, feel free to add them in as we work through. So let's have a look at how our AI agent is getting on. Cowork, so Cowork doesn't do that. Hey doesn't Cowork do that? I have to say I use most of my AI agents in my own harness in the things that I've set up. So I don't utilize it within in the web-based applications, because essentially I want to be able to make sure that I have much more autonomy over it. So when I run things, I run them in a terminal through VS Code, which is essentially where all of my information is on the system, where everything that I want to do is able to be kept. So essentially that's where I keep all of the information that we have, and that's where I've built my harness around it. So Cowork is a kind of harness. It's almost like giving you the harness, whereas what we're utilizing, what you're seeing today, is one that I've built. So you've got a combination of being able to kind of keep those things together. But chronological timers aren't anything new. They're one of the oldest parts of computing, and it's being able to set a timer and say, you know what, when we have the clock hit X, Y, and Z, go and do something, is something that's not very new. The difference is the thing that is a little bit new, which is then combining that with your AI agents to be able to get them to go and complete tasks and stuff like that. So thank you very much for your question there. It's useful to be able to kind of look through these things, and there's so many different AI setups. One of the reasons that I'm trying to do this is a visual point of view, rather than just give you a hey, use this product and use that service to be able to do it, is to try and help you understand what's going on rather than just what tool are people utilizing. Because there's so many different ways to be able to do it, and this is where you can start to get some of the value from being able to see that as well. And cool, thanks. New to the world. This is the whole point of these things. We've all got to start somewhere, right? And it's a changing world. And honestly, some of these sessions that if I was to look at vibe coding 3 months ago, 4 months ago, how I'd be setting it up and what I'd be doing with it would be different. Because things are evolving and changing so quickly that sometimes you need to be able to kind of adapt to what's going on within these spaces. And I suppose the main thing that I would take as a takeaway from that is find the things that work for you. There's not necessarily one golden way of being able to do this, one correct system. It's about building those things around how you operate, how you work. So let's check in on our AI agents here. We can still see it's going through some of the research pieces. So let me give you an idea, particularly if people are new and they're looking to kind of walk into this world. Let's have a look at the actual setup that we have here. So this is my setup. Other people are going to have different ways of being able to do it, but there's so many different ways that you could go about it. So at the moment, you've got my ZBook, which is the laptop that you're seeing everything on at the moment. That's my laptop that I'm operating my AI agents through. And I'm doing that through a free application called VS Code, probably the most common engineering tool that's out there. It's just basically a way of being able to store your projects, your data for all of the things that you're operating through a file that kind of works with it. So essentially, you can use it for your coding, you can utilize it for your agents through extensions and stuff like that. Even that VS Code that we can see doing all of that work, that is what kind of connects everything together. Then we have our Claude Code, which is the AI agent that I'm using. You don't have to just use Claude Code. You could use Codex, you could use local models, but all of these things connect together. And this is how our agents kind of essentially start to operate everything we're doing. You can see that I have Claude Code has Codex access. So sometimes if I'm working on a big project, I'm like, I want to have a second AI agent check over the work that's being on. I want someone to check the homework. And basically setting a group project for AI agents, I'll go and get Claude to access Codex as well for them both to try and solve the problem in order to kind of get two language models to be able to get the better results. We've got Camino, which is the server that we're talking about. That is the computer that they're all operating on. It's a high-spec Dell Alienware PC to be able to kind of make sure that it is able to go and access all of the different tools that it needs. It's a 24-hour server, so it sits on. And it also means that a lot of the things that I do, particularly when I run local models, that doesn't go through data center usage. That all goes through my own home server. It also keeps my data safe, keeps it storage having to be stored elsewhere. So, less points of attack for potential hackers or anything coming up. And you don't have to spend a lot of money to be able to build a server. If you've got an old laptop that's sitting there doing nothing, you could probably build a server very, very easily, very, very cheaply, or for near enough nothing. There's some tutorials on my site if you want to be able to kind of work through some of that. We have, just learning Claude Code at the moment. So this is super useful. I'm glad that it's useful. It's just a different way of being able to kind of look at it, really. I suppose you see a lot about it, and until someone sits down and explains how it's working with you, it's very hard to understand this bit. So essentially that server has the two applications that I operate, Nerve, which is this bit here. This once again is sitting on a server, and Brew, which is like the back-end platform that I do things with. These are custom build. They're not like anything that you just go and build off. You have them there. And then you've got the AI agents that are working around the clock. So we have some that are developing what we're developing at the moment, and then we have some that are what are persistent AI agents. One of the things that I'll show you now, we're going to have the live vibe coding session that we're going to do next week is a lot better example, but I wanted to give you a sneak peek on it. Is we're going to use basically Pokemon to be able to explain how AI agents work. So we'll go into this in a lot more detail, but what you can see is this is essentially what's happening in the terminal at the moment. This is live basically. What you can see is our AI agents are little Pokemon characters. They're running in this 8-bit office. And what you can see is our orchestrator agent that's sitting in the top hand corner is basically giving the other AI agents tasks that they need to go and do. So that's the difference between your agent and your sub-agent. Then you've obviously got me sitting around in the middle here, being able to run around the office. So what will happen is they'll go and complete those tasks and then bring them back. We're going to go into a lot more detail on this next week's live vibe coding session, where we use Pokemon to be able to explain this in a lot more detail. But we'll have a look at agents that are working in the moment versus agents that we're spinning up to do specific things. So yeah, we can have persistent agents that sit there all day long, or we can have ones that jump on when we need them to. But we can see that one of our AI agents there has just completed a task. It's going to go and hand it back to our orchestrator agent. And this is just another way of visualizing exactly the same thing that's happening here. You know, they're not different things that are happening. They are the same thing, just different visualizations of how AI agents work. So we saw the agent disappear in the other visualization. We can see it happening within this one as well. And all it's doing is these AI agents are going, as the AI orchestrator is going, this is the next task I need to do, right? If I want to get to this outcome, this is how I go and do it. And that's one of the cool things, is you want to be able to set the goal. If you can set the end state really well for your AI agents, then you're able to go and get a lot of results from what they're producing, which is a great way of being able to do it. This is where I always talk about the most important skills for you in the age of AI is not coding skills. It is being able to be clear with your outcome, being able to describe what you want and have a clear idea of what you want it to look like at the end. Because if you can describe it, you can create it. Let's have a look at how we're getting on. So I have a little test demo link that we use, and we can refresh it and see how things are working through at the moment. So we can see at least we have an application that's been built here, and I can start to see the ways that it started to do that. So what we have, should we automate this? Describe a process in your business, and let's see if we can do it. So let's use the example of you'll see my ability to type and talk is non-existent, but let's see how the application that our AI agent has built, if it's able to go and do this. Like this says, being honest with you as a thinking through process. But we'll leave that working to see what it comes up with. And this is just a really good example of how we can kind of create things that work for our business. I've got a question there from Patrick. Do you think we are likely to see the majority of users on local models in the futures, or the majority of organizations? Fantastic question, Patrick, and I'm very glad that you asked this. I think you will see a lot more local model usage, and I'll give you the reason behind that. First of all, is from a security point of view, if you're an organization, you want to be able to make sure that your data isn't always being sent to someone else's server in order to be able to utilize AI. And you're beginning to see this happen from a hardware point of view as well. So if you look at NVIDIA and Microsoft's new partnership, what they're doing is they're building NVIDIA Blackwells which is an AI data chip, basically a GPU designed specifically around AI models. And they're building those into your laptops, computers, and everything like that. Because for the majority of day-to-day usage, you don't need to utilize a frontier model. Unless you're coding like I am, you're utilizing Claude Code and you're trying to design complex automations. You don't need to have anything that's that complex. If you're utilizing it to come up with a proposal and have a bit of a spitball of ideas and everything like that, you can already use local models to be able to go and do that. Where you'll notice the difference is when it comes to doing things like we're doing today, where we're building an application and stuff like that. I would say a local model could probably get away with being able to build this, but I wouldn't say it would do it 100% well. I'm going to share just a window so I can make that text a bit clearer for you all. But it will get there in 18 months. Like this is well, not even 18 months. I'd say probably a lot shorter than that. Let me see if we can make this a bit bigger so it's easier to read. There we go. So what you will see is in the next, 18 months or so, sorry, 18 months, 8 months or so, your local models will be able to perform as good as your frontier models do. we will get to that point in time where you are able to essentially run all these things on your device. And it makes a lot of sense from a business point of view. Where you'll start to see the need for continuing utilizing OpenAI, Anthropic, and stuff like that is when you're looking at cutting edge and you're essentially utilizing compute that exists outside of your computer, where you're going to need a data center in order to be able to process that information. So I definitely think it's the future. There is lots of guides, once again, on the website. If you are looking at being able to set yourself up with these kind of things, if you go to Bykov-Brett.net, go to the Learning Lab, you'll see there's a huge amount of resources here that can help you out. And specifically, if you're looking at learning how to utilize local models on your computer, if you go to resources, and I think we're just a little bit further down, which is the local AI playbook. There you are. That's the one that you want. This one will give you basically the information you need of how do I run this on my computer with what kind of information, what kind of settings. You'll be able to run it on a local, basic AI models. You'll be able to run on whatever spec machine you have at the moment. What you need to do is make sure that you know the spec of the machine if you can, and you'll be able to run probably 800 billion parameter models on your computer. You just kind of match basically your RAM capacity with the size parameter of the model is kind of like the way to be able to do it. But this guidebook will walk you through being able to do all of that kind of stuff. Could you give, so let me jump back onto our AI agent. First of all, let's have a look at the application and see the results that we got from this. So we got a high confidence result, which is good. I would think that automating contracts being sent out should be something that we'd be able to automate. It's probably one that people already utilize. So it's a good example to start with. So what we can go is we could probably roughly save ourselves about 1 to 3 hours a week, about £800 in a £800 to £3,000 a year through doing this. So it's come up with a really good judgment based on the answer we've given it. And this is just a really simple application. As I said, if you can think about it, if you can imagine it, you can create it. I did this because it's a question that I get asked a lot. But I see this done quite a lot with marketing teams, when instead of going, actually, we're going to go out and buy an application, we could go, you know what, we get these reports in every single week from journalists, and they're asking us questions, and we're trying to figure out which ones are the right ones to be able to do. Well, we can all automate that. We can give an AI access to our inbox in order to achieve those results. So we have Patrick. All right, might not be able to do it now. I think you probably will be able to do it now. Like if you're looking at utilizing local models, genuinely check out the resource guide. I've got it working on such old PCs. You for lower parameter models, you'll be able to do it. And there's guides in there that can walk you through it. Have another question there. Could you give an example of what these AI agents are doing for you? I definitely can. Let's see what's the best way to be able. I tell you what, we'll go to our little Pokemon office. So let's go down to our marketing and communications team. So I was talking about local models and persistent models, right? And essentially, sometimes you just need to spin up an AI agent for a process, and sometimes you need to be able to keep them there working in the background with a persistent memory. So this is our marketing department, and we can see that we've got one. So Lucretia checks through things like terminology guides every week. So we create new terms, we're working within our business. We're creating different ways of being able to say things or things that are going to be specific to our business. So Lucretia's job is basically looks out for all those different terminologies and creates and adds to our terminology guide every week. So essentially, when I go on to do coding in the future and I say, oh, we were working on X, Y, and Z, it understands what those were. So it always has information to come back to. Let's see what other ones we have on our marketing floor. Tell you what, another good way of being able to look at this is let's go to our hierarchy map. So this is the agent teams that we have here, the office that we have for our organization. So I have our Sherlock, our chief of agents. Essentially, if I want to ask something, I just go to Sherlock because Sherlock has access to all of the other agents. Then we have our heads of department row, which essentially each of them has a team. So one's working on a marketing team, one works on projects and innovation, one works on sales and clients, and one works on products and innovation. So projects and strategy and products and innovation. So essentially, they orchestrate all of the agents that are below them, and each one of those agents has a specific job. Moonbay, for example, looks at bids and proposals. So every time we have information come in that might be a potential client, it goes and designs a proposal that would work for that one. And because they're persistent agents, they have this knowledge base, like we keep them learning. So therefore, it keeps doing things better and better and better as it goes through. So yeah, just a bit of an example. There's loads of ways to do it. Once again, if it's repetitive, involves a lot of text, or you could teach an intern to do it, you can teach an AI to be able to go and do it. Follow-up question, which is, outside of the boundaries that you talk here, is the implication of all new data center production happening? Is the implications for all of the data center production happening now? It's a good question. And data centers is one of those ones that it is it's a tricky one to be able to know. The reason that there's this data center boom is because they are trying to build better data centers. They need higher spec models, they need higher spec equipment, more capacity in order to be able to kind of build these data centers. However, they're scaling it at a level that's completely unprecedented, and you don't know if you actually need that level of capacity as things move forward. So I suppose in many ways they're trying to build an infrastructure for something that they're not very clear on. They don't have a clarity of what the outcome will look like. And that is problematic in lots of ways. A lot of the time, this is being done in the States, and that's because the States is basically the cloud hub of the world, really. It runs all of our services from that point of view. And they want to remain at the top of this kind of cloud hub of everything running services. The problem is also with the States, though, it can be a little bit capitalism on steroids. And what you generally have is they build it the fastest, cheapest, and where the legislation is weakest, which means there are environmental concerns. There are the way that the scale in which they're building that, the land that they're utilizing to be able to do it, is often they do it without the concern for the people that are going to be impacted it. Be that because the grid is going to be impacted by that data center, and there are solutions for this. I'll take you to a good little visualization we have here. So data centers, there are most data centers, particularly in the States, they're utilized in this kind of very much take the water from the local people, take the power from the grid, and it basically makes it cheap for the people that are building it to be able to do, but it makes it expensive for the people that are in the area, because those costs aren't lost. The environmental costs, the electricity costs, the water costs, they're paid by the local people still. So it's not like these people save on money, they just pass it further down the chain. There are solutions to being able to do that, where data centers are genuinely useful. You can utilize purple pipe data centers, which utilize sewage water instead of fresh water. And actually, the heating up of the water that happens through data centers is part of the treatment process. So actually, it provides a social good from that point of view. But most data centers aren't being built with this in mind. They have those options. They are choosing not to do it because it's cheaper and faster to be able to get it out there without having to do that. There's places that you have in places like Sweden, where you have data center where the heats actually heat the homes in the winter. So all of that heat that is produced is actually utilized for a purpose. In China, you have quite a lot of submerged data centers, or growing amount of submerged data centers. So they sit within the water keeps them cool. You're also beginning to see them being not submerged, but oceans data centers, where it's utilizing tidal power for energy, and it sits on top of the water rather than sitting under the water. Once again, looking at the environmental grid, utilizing renewables, supporting the grid. So yeah, there's great ways of being able to do that from that point of view. Other ones that you can see is particularly up north, what you get is much more being able to build data centers in cold areas. So essentially, you don't need to worry as much because it's free cooling, so you don't have to focus as much on taking from the grid. And one thing that I'm seeing a lot more proposed of, particularly from NVIDIA at the moment, is actually small data centers that you can attach to your house. Okay. And what I mean by that is they pay you to use your land for a data center that's kind of as big as it, like it's, I suppose, not quite as big as a shed, maybe just a bit of a unit that sits on your ground, on your land. And actually they pay the energy costs and they pay you for being able to have their data center bit there, this little micro data center, and then it goes into being able to support the local community, and it gives you a financial benefit of having it on your site. So your energy bills are free, and you are utilizing your land to kind of for the social benefit. So that's definitely something that's being explored as well. So there is a lot to consider when it comes to data centers. As I said, one of the biggest challenges is people are doing it cheap, fast, and where the legislation is weakest, and doing it so it has social harms that it doesn't have to have. Once again, we should probably kind of come to the discussion around whether we should be scaling things to meet demand, or whether we might have to curb demand in order to align with the scale of what we can produce and what's reasonable to produce. So hopefully that was I feel that was a long-winded question, but hopefully a long-winded answer to a question. I'm glad I've got the visualizations there, because it's the main concern that lots of people have. So I always want to make sure we're addressing that as well as possible. I want to thank everyone for we had amazing interaction today. I'm so pleased that you're able to come on and ask questions, and hopefully you found something useful from it. We probably did a lot less on looking at what we're building today, and a lot more on being able to look at how we're building it. But we did get our application in the timeframes that we're looking at, an application in half an hour, built with just a clarity of what to be able to do. But hopefully you found that useful. Hopefully these guides give you something to be able to work with as well and get you started on the journey. And you'll be flying in no time. If you'd like, I'd love for you to be able to join us for future sessions. We have our fortnightly review on Tuesday, where we go back and look at all of the last couple of weeks, what updates there are, what information you might want to know, everything like that. And we also have a vibe coding session next Thursday, where we'll be going into utilizing Pokemon to explain how AI agents work and how our AI offices can all come together. So we had a bit of a sneak peek today, but we'll be going into a lot more detail on that one as well. As always, if you want to be able to purchase my services in terms of education, supporting your business, consultancy, anything like that, do reach out to me, Jamie Bykov-Brett. Go to Bykov-Brett.net, spelled BYKOVBRETT.net. And then essentially you can get me through that, or connect with me on LinkedIn or any other socials. I am at Jamie Bykov-Brett on everything. So thank you so much for your time, energy, and effort today. Hopefully you have a fantastic end of the week, and we'll catch you all very, very soon.